All right, welcome back. So this is part 2. So far we've seen the basic mechanisms of working with the Jupyter Notebook. We've seen the basics of Python types, but we haven't really learned how to do anything except assign variables and print them out. So this is what we talk about now. We talk about Python control structures. So probably the most basic control structure is the if statement. And let's just look at an example. Again, this looks pretty much like executable pseudocode and syntax if. You can see it's a keyword because it's green and bold. If, then something, something, something. So here's a condition, colon, and then a block. Else, colon, and then a block. So what do I mean by a block? So Python is a little bit unique, maybe not amongst all programming languages, but at least amongst the most widely used ones, that it uses indentation to delimit blocks. So this is also sometimes called the offside rule. So if you have a statement like an if statement, colon, and then here, we have 4 spaces something, 4 spaces a statement 2, 3. So all of these statements that will be indented, these constitute the block. And actually, from the point of view of the language, you can use as many spaces as you wish. You can even use tabs, but please don't do any of those things. Please just use 4 spaces, because that's not a feature of the language per se, but a convention in the community. And in fact, if you look at the Jupyter Notebook or any other type of IDE tool, they will give you 4 spaces if you press the tab key. So here I'm pressing the tab key, and as you can see, every time I get exactly 4 spaces. And if I delete 4 spaces. So for all practical purposes, blocks are defined by 4 spaces. All right, so this does what you'd expect it to do. The flow of control goes from top to bottom, gets here into the if, evaluates the condition. If the condition is true, it executes this block. Otherwise, executes the else block. All right. All right. So conditions. So we've seen that Python uses the equals operator to mean assignment. So a equals something assigns the name a to that thing. And so to do a equality condition, we use the equals equals. So again, a lot of the languages in the C family use this convention. Not equals is spelled !equals. Then we have the greater than, less than, greater equals operators. Those work exactly as you'd expect for numeric values. I think with strings they should probably do the alphabetic sorting, and then so we also have these 2 operators so we can check if A is in some list or if A is not in some list. And actually here this can even be a bit more generic. There's a A in some sort of sequence. So when these do what you'd expect them to do, right? If A is an element of the list, then it's true. All right, so else and friends. So we've seen that we have if statement, we can have an if and an else statement, and we can have an else if statement, which in Python is spelled elif, E-L-I-F. And so in this case, let's just execute this. So A equals 2, and then each of the conditions will be evaluated in order, and the block corresponding to the first condition to evaluate true, that will be executed, and then the rest will be ignored. So we'll skip. The else clause is optional. So in this case doesn't work, and actually everything is optional. So we can even just have an if statement, right? So probably nothing too surprising here. Okay, looping. So again, let's start with syntax. So looping, so we have the for statement, and we have for, and then something, a name that we define in, the keyword in, and then a sequence. So the simplest type of sequence that we've seen is a list. And so here, let's say we have a list of 3 students. So a list of 3 strings. And so here, and then we have a block. Again, a block is something defined by 4 spaces. And that block will get executed one time for each element of the list, where this name, each time the name will refer to that element. So, boom. And as you can see, this is one of the reasons why Python is so easy to teach, is that the syntax is really very regular. So we have some sort of keyword, some sort of keyword specific thing, a colon, and then a block defined by indentation. And so and this will show up again and again. So if so we'll see in a minute that everything follows this syntax. All right. So with so as I said, we iterate over sequences, and the simplest type of sequence is a list, but we can also iterate over dictionaries. And so in that case, it corresponds to iterating over the keys of the dictionary. So here is the N will be the first key, the second key, and so on, so on. And then here we can use the keys, for example, to access the dictionary. And so we can iterate over dictionaries. All right, we have a while loop. And so here I'm sort of, by now, you can probably guess the syntax of a while loop, right? Because everything's so regular. And indeed, we have while, then some condition, colon, and then 4 spaces to indent the block. So here let's do division. So poor man's division, where we just repeatedly use subtraction, and we start here with these huge numbers. And all right, and yes, indeed, our very bad method of doing division works and returns the same as if we had just used the / operator. Okay. So in many languages, when for loops are either restricted to being over integers or have some sort of special syntax for iterating over integers. And in fact, it's often very useful to do this type of iteration where we go from a number up to another number. And in fact, in Python, so the for loop itself is over a sequence, but there's this utility function called range so actually it returns this weird type of range object. That's technically, this is called an iterator. We won't really go into that here, but what the range object does, and so here we're asking for an object that a range from 0 up and to, but not including 5, and actually and we can also just use the simpler form range 5, which is actually the same thing. So if you just give it one argument, it assumes that that's the end, where the end is always up and to, but not including. And so this allows us to iterate over I, so this goes from 0 up and to, but not including 5. Okay, so maybe this up and to, but not including structure seems a bit odd, but remember that in Python, lists use indices starting at 0, and so range of 5 are exactly the indices that are necessary to access all of the elements in a list with 5 elements. So you'd have index 1, the first index 0, the first index 1, all the way to index 4. So up and to, but not including 5. Conditions. So we've seen conditions implicitly. Say A less than B. But we can also use them. We can also use them in other contexts, and they return these Boolean values. So just print them out. They return true and false, which in Python are spelled capital T, R-U-E in lowercase, and capital F and the rest. So they're spelled in only the first letter in uppercase. So when we've seen this as well in others, so for example, the none element is also spelled with the capital first letter. And we can use these booleans as values. So we can assign, they're objects like any other thing in Python. So we can assign them to names, and then we can test them. And in fact, many things can be tested and can be used as conditions. So a list can be used as a condition, and the rule is very simple. If the list is empty, that's false. Anything else is true. So it doesn't matter what the content is, just matters whether the list is empty. The dictionary is the same thing. You can have an empty dictionary, which corresponds to false. Everything else is true. An empty string is false. Anything else is true. A 0 is false. Everything else is true. And in fact, there's other objects that can be evaluated in conditions. So we also won't talk about it today, but in Python, you can define your own types, you can define your own classes, and you can define what it means to evaluate them as conditions. So if you have your own class, then you can do whatever that class definition is that will be evaluated here. Okay, so fruits. Remember, the fruits was this list that we had with bananas, and then we even added some random numbers and stuff. And so it's not empty; it's still fruity, right? Okay. So loops. So we've been talking about loops. And so we loop over things, and there's two special keywords. There's the keyword break and the keyword continue. So break stops the loop immediately, and continue goes to the next iteration of the loop immediately. So if you're in the middle of the loop, it just goes to the next one. So here's the very similar example to the one we started off with at the very, very beginning. So we have a list of numbers, except that for some reason, so here we've had some negative numbers, and let's say in this problem, we don't care about negative numbers. So we want to ignore them because they might represent some condition. So we want the average of only the positive numbers. Oops, and here's a typo, I guess, from all right. And so we have here, as we had before, total is initialized to 0, n is initialized to 0, and then we loop over the numbers, and if a number is less than 0, then we continue, so it will go to the next one. And here I've also introduced this plus equals operator, and plus equals is just a fancy way of spelling total plus equals v is a fancy way of spelling total equals total plus v. So these are exactly the same. I guess as I was testing the presentation just before taping, I guess I left some edit errors. All right, so these are exactly the same. So we have plus equals. Again, many other languages like the C language in that family have a similar operator. Plus equals, minus equals, slash equals. You even have the slash equals, which invokes the integer division operation. So they all work the same. So you're doing a slightly terser version of doing the operation and then assigning the name. Okay. So far so good. Let's look at functions. So we've been calling functions. We've been calling the built-in print function from the very beginning when we did print hello world. We've called other built-in functions, but let's now define our own. All right, let's start. Syntax. As usual, some keywords, the keyword def, def, to define a function. Then double, that's the name of the function that we're defining. And then arguments using parentheses, a colon, and then a block. Okay, again, very, very regular syntax. Let's ignore this red part for now. All right, let's ignore this we ignore it for now, and then return 2 times x. So return keyword again returns the value. So double 3. Right. You can have functions that don't return anything, actually. And so, for example, let's just do this. Forgot to type the return function, and then it doesn't return anything. And if we actually print it, we get this none object. So remember I said the none object doesn't do anything, but sometimes it ends up popping up to represent the absence of something. So in Python, we have to explicitly return if we want our functions to return a value. All right, so this red thing here, you might think, oh, that's just a comment. We've maybe just a fancy way of doing a comment. We've seen that normal comments are with the hash. So this is a normal comment like this. Normal comment. And this is a documentation string. So what does it mean? What does that mean? It means that if we use this question mark operator that we saw before to get help, right? Remember, it pops up this help function, and so here, double takes an argument, and docstring returns the double of its argument. So this was exactly what we wrote here. And if we write returns twice the input, or twice its input, I guess it's better, slightly better. And then, all right, see? So in some ways, yes, it is a type of comment, but it's, number one, is a special thing that the language supports and then integrates very well with, in this case, Jupyter, but a lot of the other IDE type environments also support getting that documentation string quickly. And so often comments are more about what the code is doing or trying to explain to the next person who's reading the code why the code works in a certain way that might be not so obvious. Whereas this documentation is more intended towards the people who will be calling the function. So someone who will be a user of the function who might not be interested in how it works internally, but is interested in knowing, what, if there's multiple arguments, what do they all do? So it's not really the same thing as a comment. It's documentation, not a comment. All right, so calling a function. All right, so we've kind of seen this. So you call a function, name of the function, parentheses, the argument. So here, just to see, so here we've used first an integer argument, 4, and then a floating point argument, and both work. We can have more complicated expressions. This all works as you'd expect. So in Python, functions are not typed, so you do not specify the types. It's just that if you gave it something where it wouldn't work, then you'd get an error at runtime. So if we call it here with the emails argument, emails argument, yes. So you hear, it's trying to multiply emails by 2, emails at the dictionary, and so you get the type error. So Python does have type checking, but the types are checked at when things are used. Right. Okay, so functions with default arguments. All right, so let's look at syntax first. So def, we've seen this, the function greet, parentheses, first argument, comma, second argument, and then equals something, close parentheses, colon, then the body of the function. And so in this case, this function has 2 arguments. The first argument is the argument name, and the second argument is the argument greeting, which has a default. So we can call it with 1 argument, in which case the greeting will get the default value, or we can call it with 2 arguments, overriding the default. You can also just specify the name of the parameters. So we can say that the green thing is Howdy and name is Mario. And in this case, the order doesn't matter. So we can say the first one and then the second one. And this is, here, if you have two arguments, you can probably remember which one is the first and which one is the second. So some functions can easily grow to many arguments, where often the use case is you have a data argument, and then you have a bunch of parameters that are internal, and they will all have default values. And then you want to override, say you want to override the learning rate, and it's much easier to say, learning rate equals 1, rather than to try to remember whether the learning rate is the 7th or the 8th parameter. This is the breakpoint, in the sense that this is the end of part 2. So far we've seen Python. We haven't obviously seen the whole language. So as I said, there's ways where we can define our own objects. We're not going to be talking about that. That will also not be. But if you've seen any type of object-oriented programming language, you can define your own classes. But we've seen the basics. We've seen how to use the Jupyter Notebook, and so in the final part 3, we'll be talking about how then we use this language to do numeric and scientific computing. But here let's stop for Q&A about what we've talked about so far.